UTP now?
No.
Not yet. Okay. Okay. So when is
No.
your plan? When you plan to back to UTP, guys?
For 10 to 12 July, this Friday to Saturday. But I think some of us is already there. Like our friend
Right.
Cyril here, he's already
Mm-mm.
there.
Okay. 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 So yeah, welcome to UTP. And uh, hmm, happy safe journey for those who are in your journey now. Some of you that are from Sabah and Sarawak, especially. Okay, so so for today's lecture, I'm going to continue to the inverse function for log and exponential function in chapter 2.5.
Oh, okay.
Okay, so our last lecture, our last discussion, last week 5 is about inverse function, but for square root and also quadratic function. Okay, so today let's continue to the log function. So I'm going to take one of the example here. Okay, before that, is there any question regarding the inverse function for quadratic and square root function?
Um, so far no. I didn't attend the last class, but I rewatched the recording, so I think I'm alright.
Okay.
Yeah.
Okay, if no, I will continue to the today lesson. Okay. I take the second case here where the base is greater than 1 first. Okay. Later on we will look at the case 1. Okay, as you can see here, the difference between case 1 and case 2. Okay, when the base is less than 1 greater than 0, there is intersection between f and f inverse function on the graph. Okay, if the base is greater than 1, okay, as you can see here, there is no intersection. Okay, so now if the function fs given is log s with base 2. Okay, so find the f inverse function. So remember the step, you have to let the fs equals to y log s with base 2,
Mm-mm.
and then
Switch
Make x the subject.
x
yes,
equals
interchange s and y. Sorry, yes,
y.
y. And then make y as the subject. So for
Dia
this one,
pindahkan.
yes, pindahkan. You have to use the
So
law
x
of
equals
logarithm.
to
Y equals to 2 to the power
2
of
power of
2x.
x.
s. So y is equals to f inverse. S equals to 2 to the power of x.
X.
This is your
Eh,
f inverse. Okay, and the continuance on this, you have to find the domain and range for fx and f inverse x. So the domain for f is, okay, when we sketch the graph for log s with base 2, since the base is greater than 1. Okay, so you know the graph is going upward. So as you can see from this diagram, the domain is from, and what is the range? It is from, yes, what is
Range domains.
domain for f, domain for log function? Remember to find domain for log function?
domain is
Is zero to infinity.
Yes, equal to positive infinity. Very good. And the range is all real
Real numbers.
negative infinity to positive infinity.
I
And
like how I
to get the domain for f inverse, you
just
just
take the range of the log function.
Yes. So it is negative infinity to positive infinity, and the range is from 0
Zero
to
to
positive
infinity.
infinity.
On account I
And the
can never
last,
remember. I have to look at the graph always.
okay. So there are two approaches to find domain for log. Remember, first by using graph. The second one by looking at the things inside the bracket here. Okay, so domain F we let S greater than 0. So this is your domain, which is 0 to positive infinity. And vertical asymptote for log function we let S equals to 0. So this is your vertical asymptote. Okay, so this approach without using a graph. You're still able to define or to determine the domain and vertical asymptote for log function. Okay, next you have to sketch graph F and F inverse in the same axis.
Mm-hmm.
Okay, you have Y and S axis. And this is the vertical asymptote S equals to 0 for log function. And F inverse will reflect about the line of
That will reflect the line of what do you call that line?
Y equals to X, right?
Yeah.
Okay, this is it's not good. It's supposed to be reflecting about Y equals to X.
So end up there is no intersection.
Yes, there is no intersection. And you also have, okay, for this question you have to clearly label the F curve, the F inverse curve, the reflecting line, which is Y equals to X, and also the vertical asymptote, S equals to 0, and the
Horizontal asymptote.
horizontal asymptote, yes,
Okay.
Y equals to 0. So the marks will be given at this asymptotes, reflecting line, the curve of F inverse, and the curve of F. Right?
Mm-hmm.
So that's all how to find inverse when given log function. Okay, same. If the question start from, if the given F is 2 to the power of X, so you have to find F inverse. Okay, so in order to find F inverse when given exponential functions, okay, you have to go through the same steps. Okay, we let Fs equals to Y, and then interchange X, and then solve for Y. To solve for Y, how yeah?
To solve for y, log 2x equals to y.
Okay. Okay, for this case, we put ln.
Ln. Oh wait, I have not learned how to use this yet.
Okay, we haven't go through the solving exponential part first. We haven't touched the 2.6 subtopic. I just show this one. Later on, we will discuss further in details regarding solving exponential equation. Okay, so when given 2 to the power of x, when given exponential function, you have to solve for y. So in order to solve y here, you have to put ln for both sides. Ln 2 to the power of y. And then what is y? And then by using the law, we bring the power in front. So you will have y ln 2 equals to ln x. And then y equals to ln s over ln 2.
Oh wow. Okay.
Okay, y equals to ln s over ln 2. Or you can also write it as okay, wait. So this is also by using log m base b equivalent to log n over log b. Okay, so for this case, when you use this law, you will get y equals to log s base e. Alright. Log s, base 2. Can you relate this?
Wait, let me look at it for a while.
Yes.
Okay. Oh, okay. I maybe I can. This is the law
Mm-hmm.
of log of law of logarithm. So state that. Okay. So it is equivalent to log m divided by log b or ln m over ln b.
Okay.
Okay, so now you have ln s over ln 2. So it is also equivalent by using this one. It is also equivalent to log s with base 2.
Oh, okay. I see. Yeah, understand now.
Okay, so
Yeah, I get it.
log s with base 2. So the f inverse s is equals to log s base 2. Okay, this is how to find f inverse when given exponential function. Okay, so I think that's all in this subtopic 2.5 regarding inverse function. Okay, I will give another exercise later. Okay, if there's no question, can I continue to the next subtopic? Okay, the next subtopic actually is 2.6. 2.6 is about solving exponential and logarithmic function. Sorry, equation.
Solve for x.
Yes, you have to solve x for exponential and log equation.
I see. Okay.
Okay, this one 2.6. And then in 3.1, you will have polynomial. Okay, for polynomial, in 3.1, you have to perform division operation for polynomial. You have to divide polynomial. Okay, you have to divide improper polynomial by using long division technique. Long division. Okay, in 3.1. In 3.2, it is about rational function. In rational function, you have to find domain, range, and asymptote. Okay, and in 3.3, you have partial fraction. Okay, partial fraction. So 3.1 and 3.2. Okay, wait. Okay, so today we are going to continue our lecture to 3.3, partial fraction. The first three subtopics here, I will do recording and upload it in uLearn. So you have to go through it in uLearn.
Okay. Wait, so we're not having like a class of this?
Yeah, there is no class for this three subtopic.
Wow. Okay, so we have to go learn. It's already uploaded in uLearn?
Not yet. Once ready, I will inform.
Okay.
Okay, so I will focus on 3. For today, I will go through 3.3 first, and then next week, this coming next lecture, lecture 2 for this week, week 6, we will continue to 4.1. Okay, because your test will be on next week on Saturday, so I try to cover the syllabus, and then the remaining time we will spend for the revision. Okay, so maybe for the second lecture next week we will do revision. So for 2.6, 3.1, 3.2 also included in the revision part. Is everything clear?
Yes.
Okay. So for partial fraction today, okay, chapter 3.3. Okay, so okay, look at the learner outcome here. At the end of the module, students should be able to decompose PS over QS for different type of QS. Okay, PS over QS, it is what actually? It is a rational function. Okay, so RS, the rational function, is PS over QS, a polynomial divided by polynomial. Okay, and you have to consider the QS. QS is the denominator part. Okay, at denominator part you have to identify whether it is linear factor or irreducible factor. Sorry, irreducible quadratic factor. Okay, for linear factor, the general form we can write it as AS plus B, and for irreducible quadratic factor, AS square plus BS plus C.
So basically, anything that has more than one root.
More than one root for which one?
Yeah, irreducible quadratic factor. That means x can be multiple numbers.
No. For this one, for irreducible quadratic factor, you cannot reduce this expression anymore. This is the factor that you have. You cannot reduce it to x power of 1. Okay, maybe I can give an example here. For linear factor, 2s plus 1 for example, and for irreducible quadratic factor, s square plus 1. Okay, for s square plus 1 or maybe s square plus 2s plus 1. Okay, this is example of irreducible quadratic factors where you cannot reduce this into another factor.
I see, okay.
Okay, if you use your calculator, you will get the root is in imaginary number. Yeah, the root is imaginary, which is not real number, so we cannot consider that. There is no root actually. Okay, there is no real root for this case, for irreducible quadratic factor. So you have to identify these two factors, the type of factors, and then you need to consider these 4 cases. Okay, the first one we call it as the first case is when the denominator part has only distinct linear factors. Distinct linear factors mean different linear factor. So for example, okay, for case 1 here, for case 1, if you have 1 over s minus 1, s plus 7. So this is for case 1, when you have a distant linear factors. Okay, when you have only distinct linear factors.
Okay.
Case 2, repeated linear factors. Okay, repeated linear factors, for example, s plus 1, s plus 1. Yeah. Okay, or you can also write it as exponential form, power of 2. And for case number 3, distinct irreducible quadratic factor, 1 over s square plus 1 and s square plus 2s plus 1. Okay, this is distinct irreducible quadratic factor. And for case number 4, 1 over x squared plus 1 x squared plus 1. Repeated irreducible quadratic factor. Okay, so there are 4 cases that you need to consider. Okay, before that, let's look at the Okay, look at these terms, partial fractions. What does it mean actually for partial fraction? What's your idea?
Partial fraction.
Okay, I give you this. Okay, I give you the idea here. Okay, when you have 3 over s plus 1 and 1 over s plus 2, how to solve this? How to write it in single terms?
First convert the denominator to be the same.
Okay. Okay, we want to make it, to express it as a single fraction. So we make the denominator same. Okay, so s plus 1, s plus 2. And then simplify the numerator part. 3s plus x, 6 plus 1. So you will have. Okay. So now this one, okay, when you expand the denominator part, you will have s squared plus 2s plus s plus 2. So 4s plus 7 over s squared plus 3s plus 2. It is also equivalent to 3 over s plus 1 plus 1 over s plus 2. Okay, so the idea for this subtopic is given, it is a reverse process. Okay, reverse process. Given a single compound fraction, and then you have to decompose or express it in sum of 2 or more partial fractions.
Oh.
Okay, you have to express it in this form.
So partial. Oh, okay. Got it.
Okay, so from the given fraction here, the given is the proper rational function. Only proper rational function you can express it into partial fraction. Okay, again, only proper rational function you can express it in partial fraction. Okay, so now how to determine whether it is proper or improper? Proper rational function. Okay, so, if n is the highest degree at numerator and m is the highest degree at denominator. Okay, so when you have, for example, here s squared plus 1 divided by s cubed plus s minus 1.
Okay.
What type of rational function that you have here? Proper or improper? Look at the highest degree, n, at numerator.
It's proper.
Yes, it is proper.
So we always look at the highest power?
Yes.
Okay.
Okay, so you have to look at the highest power at both numerator and denominator. If n is less than m, so it is proper.
Got it.
Okay, I'll give you another example. If s squared plus 3 divided by s squared plus 1.
Improper.
Yes, improper. When it share the same degree, when n equals to m, it is improper rational function. So you cannot express it, you cannot direct straight away express it into partial fraction. You have to reduce it into proper first, then only you can
convert to improper.
Yes, convert to
partial
fraction.
fraction.
Okay, so the next example, if you have s to the power of 3 plus 2s plus 1 divided by s to the power of 2 s power of 2. So n is what?
N is 3,
And m?
2. This is
And-
improper.
Yes, also improper rational function. So there are two conditions to have improper rational function. One, when it is equals to m, and another one when it is greater than m. Okay, so for these two cases, you have to reduce it into proper first, then only reduce to proper, then only you can express it into partial fraction. Okay, so in order to reduce to proper rational function, you need to use, we call it as long division technique. Okay, this one I will cover in chapter 3.1. Okay, but this one we will discuss later.
Okay.
Okay, so as for now, today we are going to discuss the 4 conditions that involve proper rational function. Okay. Okay, let's look at the first case here. The first case example given here is 1 over s squared plus s minus 2. Okay.
So the partial denominator will be x minus 1 times x plus 2, right?
Okay, good. Yes. So first, when you have the proper first you have to check whether it is proper rational function or improper. So for this case, since
It's proper.
1, it is s power 0, right?
Yes.
So it is proper rational function. So when you can proceed to express it into partial fraction. Okay, show here. Okay, so first you have to factorize the denominator part. Factorize qx. Why? Because you have to check whether it is in case 1, case 2, case 3 or case 4. So when you factorize this part, it is s minus 1
X plus 2.
s plus 2.
That means this is distinct linear.
Distinct linear factors. Yes, distinct linear factors. Oops. Okay, distinct linear factors. So in order, okay, first you have to express it into this form. Look at the things inside the orange box here. Okay, a1 divided by s minus a1 plus a2 divided by s minus a2 until so on an over s minus an. Okay, so the denominator part here is represented your factors. This one your first factor and then second factor and so on. So for example number 1, there are 2 factors, s minus 1 and s plus 2. Okay, so you will have the number of fraction is depends on the number of your factors here. Okay, since you have 2 factors, you will have 2 fractions. So the first one for s minus 1 and the second one for s plus 2.
Plus 2.
Okay, so you already follow the denominator part. For numerator part here, instead of using A1, A2 until AN, we use alphabetical order, A, B, C, and so on.
Okay.
Okay, so for the first part here, I'll put it A.
And B.
Here, yes, A and B. And then, next you have to find the value of A and B, the constant. You have to find the constant A and B. So in order to find A and B, we make the denominator same. So A times S plus 2 plus B S
X minus 1.
Okay, divided by S minus 1, S plus 2. Okay, and at your left hand side, it is, as you can see here, the denominator part is already same. So you just compare numerator part.
So 1 equals to a x plus 2 plus b x minus 1.
Yes, in order to find the value of a and b. Take this part.
Oh wait, are we going to have the simultaneous equation this?
Uh,
Because
yes,
it's two unknowns.
Also can. There are several approaches you can use in order to find a and b here.
Okay, well what's the standard way of completing it?
The standard one, we compare the coefficient.
Okay.
Okay. Alright. Okay, I will show here. Okay, I show the first approach. There are two approaches that I can suggest here. Okay, the first approach, we use the root. Okay, so first the first approach only applicable for case 1. Sorry, only applicable for the case that involve linear factor.
So it means case 1 and case 2.
Case 1 and case 2. Sometimes the question also can mix together. Case 1 and case 4. So as long as it has a linear factor, you can apply the first approach. Okay, so I start from the first factor that I have here, which is s minus 1. From s minus 1, I can get the first root, which is s equals to 1. So I substitute s equals to 1 to the numerator part here. So 1 is a, 1 plus 2 plus b, 1 minus 1. So this is 0. So 3a equals to 1. a equals to 1 over 3.
Okay.
Next, I use the second factor that I have here, which is s plus 2. From s plus 2, my root is s equals to negative 2.
Negative 2.
Okay, and then substitute to the numerator part here. 1 equals to a, negative 2 plus 2, 0, plus b, negative 2, negative 1.
Oh.
So b equals to negative
B equals to negative 1 over 3, yeah.
1 over 3. Okay, so now you already have the value of the constants a and b. Okay, so that for the final answer, you have to rewrite the equation. Final answer is 1 over s squared plus s minus 2 equals to is it
1 over 3.
1 over 3 over s minus 1 plus negative 1 over
1
3
over 3. X plus 2.
Plus 2. So this is your final answer. Okay? Now I would like to show here the second approach. The second approach is applicable for all cases, but it is quite complicated when it involves complicated functions. It requires more steps. Okay, in this one, comparing coefficient. Okay, we start from the numerator part that we have here, which is 1 equals to a s plus 2 plus b s minus 1. And then you have to expand it, as plus 2a plus bs minus b.
Okay.
Okay, then you have to collect the like term. So the coefficient of s is a and b, and the constant is 2a minus b. Okay, and then you can start compare the coefficient. Before that, to make it clear, you know that at your left hand side, the coefficient of s is what? The 0, right? 0x. So 0x plus 1 equals to a plus bs plus 2a minus b. So when you compare coefficient, we start from x. What is the coefficient of s at the left hand side? It is 0. And your coefficient of s at the right hand side is a plus b. You see that?
Yeah, I see.
Then you can solve for, before that, before you solve it, proceed to the constant part. For the constant at the left hand side, it is 1, and at your right hand side, it is 2a
2a minus b. Or then you simultaneous equation from here to get a and b. I get it.
Then you have to solve the simultaneous equation.
Yes.
Yeah, miss, someone's calling. Who's that?
Someone's requesting for you to go
Oh,
a bit
explain
slower.
slower. Yeah, I see now.
Which part?
I think it's the part where you added the 0x plus 1, comparing the coefficients. I think that part some people don't understand.
Okay. Is it in the chat part?
Yes.
Be slower, please. Oh, okay.
Also, this recording started in 7 somehow.
150. Okay. C7.
Because the recording is nearly 2 hours, but it's only like 9 o'clock.
Okay, I explain at the second approach here. For the second approach, I start from the numerator part. Okay, I take from the numerator part, which is here. Okay. In this approach, you have to compare the coefficient. Okay, what is coefficient? The coefficient is the constant that attached to the function. So for this case, the function is x. Okay, the function is x. So this is what we call as coefficient. Okay, and now look at the left hand side. There is no coefficient for x. So that I add 0 coefficient for x in order to get a clear view, so that you can easily compare the left hand side and the right hand side. Okay, so I start compare the coefficient from the first part, which is x. For x, at the left hand side it is 0, and the right hand side is a plus b. And for the constant, at the left hand side it is 1, and the constant at the right hand side it is 2a minus b. Why I call it as constant? Because there is no function. There's no function attached together, attached along with these terms. And then to solve to find a and b, we have to solve this simultaneous equation. Okay, so for the simultaneous equation, okay, you can use substitution, or you can subtract the first and the second, subtract or add the first and the second equation here. Okay, I use substitution technique. So a equals to negative b, so that 2 negative b minus b equals to 1. So you will have negative 2b negative b equals to 1, so negative 3b equals to 1, b equals to negative 1 over 3.
Then we get the same answer.
Yes, the same answer. So whatever technique that you use, you should get the same answer.
I think the second approach is better. It's more, can be used on everything.
Yes, the second approach is better, but sometimes it is complicated when it involves a complicated polynomial.
I see.
So, but it depends on you. Both are accepted. Okay.
Okay.
Okay. Now let's find a. So a is equals to negative b. B is negative 1 over 3. So a is 1 over 3. Okay. So this is how to use the second approach. Alright. So that is how to solve or to decompose proper rational function that has only distinct linear factors. Is it okay, guys?
Yeah, seems simple enough. No questions so far. I'll let you know if there's any.
Okay, so that I proceed to the second case now. The second case when you have repeated linear factor. Repeated linear factor.
Oh, does that mean the partial fractions will be the same?
No.
Okay,
No,
let's see an example.
Okay. So for example, number 2, s plus 2 over s cubed minus 2s squared plus x. Okay, always start check the function whether it is proper or not. Okay, for this case, it is proper. And then factorize the denominator part. Okay, for this case, you will have what? S and
X minus 1.
square minus 2
Oh, okay.
s plus 1. And then from here, can you further factorize this part?
No,
second-
cannot.
Are you sure?
Yeah, you can't factorize anymore, right?
No.
Oh, wait. Like that.
It is
Wait, is it the
s
same?
minus 1 squared. Is it? Let me check. Yeah, 7.
Okay.
So s
Oh,
times s
yeah.
minus 1 squared, or maybe I can show in this form first.
It has
Okay,
equal
as you
roots.
can see here, the s minus 1, it is a linear factor and it is repeated.
Wait, does that mean we have 3 partial fractions?
Yes, correct. You have
Oh,
3
gosh.
factors, so you will have 3 partial fractions. Okay, so for this one, example 2. Okay, we start from s plus 2 divided by x, s minus 1 square. Okay, now look at the purple box here. When it is repeated, this is the way to express the partial fraction. The first one with power of 1 and then power of 2. It depends on your factors. If it depends on the number of factors, repeated factors. Okay, for example, for this case now, you will have 3 fractions. Okay, the first one for s, the second one for
Yeah,
s minus 1.
X minus 1. And same thing
the
again.
last one, s minus 1 square.
Square?
You follow this purple box expression. The first one, 1, and then power of 2 up until n. So your n here is 2. So you up until 2 lah for this case.
Okay.
Okay, maybe I can show another example. If you have, let's say 1 over s plus 3 to the power of 5.
Okay.
So you have to provide
Oh.
5.
X plus 3, then X plus 3 square, X plus 3 cube, X plus 3 to the power of 4, then oh my goodness.
So s plus 3, sorry, s plus 3, so s plus 3
What the
up until n. This your n here is 5, so up until n. 1, 2, 3, 4, and 5. Okay? And for this second case, okay, similar, we are not using A1, A2, AN, but A, B, C, and so on. The alphabetical order. So this one A, B, C. So we have 5 factors here. A, B, C, D until E. Okay, but no worries. This is just an example. You don't have to solve the question until power of 5. Okay, the maximum power until 3 or 4. Okay.
So now we have 3 unknowns.
Yeah, so now you have 3 unknowns, A, B, and C. So you have to find these 3 unknowns. Okay, so similar step, you have to make the denominator same. So now you have s minus 1 square. And then for the first fraction, you have to multiply both numerator and denominator part with s minus 1 square in order to make the denominator same. For the second fraction, you have to multiply it with x and x minus 1, x minus 1, and the last one with x. Is it clear?
Yes.
Okay, I proceed. So now you will have this at numerator part plus cx. Okay, so can you see here the numerator part will become complicated now. Okay, so since the denominator is already same, you just compare the numerator part.
We have to expand everything.
If you use the second approach. Yes,
Yeah.
you have to expand.
That's a lot. I can
I'm
see.
not
I
going
can see
to
why
use
it's
the second
complicated.
approach.
I can see why it's complicated now.
If the power up until 3, yes, you have to expand. Okay, numerator part, it is s plus 2 equals to a s minus 1 squared plus bs s minus 1 plus cx. I'm going to use this first approach, which is by using the root that I have. So since the first factor is x here, so x, for x the root is x. For x the root is s equals to 0. So I substitute s equals to 0 to the numerator part here. So I will have at the left hand side it is 2, at the right hand side it is a plus 0 plus 0. So that a equals to 2. For the second factor that I have is s minus 1. So the root is s equals to 1. 1 plus 2 it is 3. 1 minus 1 0. 1 minus 1 0. And then c. C times 1 is c, so that c equals to 3.
Okay.
Okay, but now to find b, I have no more factors here. Already used.
Yeah.
S I already used, s minus 1 also already used. So for the last one, in order to find b, I can just let or assume s equals to any real number.
What? Why?
Yes, because you already have the value of a, the value of b, right? So in order to find the value of c, whatever s that you have,
I thought we have C. I thought we have C already.
Oh, sorry. We already have the value of a and the value of c. Right? So when you substitute s with any number, the b should be the same value.
Okay. So how do we calculate this? X equals to IR, the real number.
No. The real number. The real number means you can substitute any number, but please choose the small and the easier number that you can calculate.
1,
What already used here?
2.
2,
2. Okay lah. 2. Okay, 2. So if you use 2, you just substitute here. So 2 plus 2 is 4. And then 2 minus 1 is 1, which is A. Plus 2 times B to B. 2 minus 1 is 1. 2C. Okay? And then substitute A plus 2B. Sorry, B, yes. Plus 2 times 6. 2 times 3 is 6. And then 2b equals to 8 negative 4. B equals to negative 2. If you let s equals to, let's say, if you let s equals to 100, if you let s equals to negative number, for example, negative 1, if you let s equals to any number, 3 so on, you should get the same value of b. Okay? Is that okay, guys?
Yes. Okay, so basically we can put any real. Doesn't that mean that our b value may be different for everybody?
B value, sorry, B value what?
Like, since that means for everyone we will have a different b value, right? If we use different.
No, you should get the same value of B because it's like factor of the numbers. Okay, it is like if you use a bigger number. Okay, for example, if you use the bigger number, maybe this is not 2 but 8. 8b equals to negative 16.
Oh, okay, yeah, I get it.
16 or something like that. If you use a bigger number, but when you find b, you still get the same value.
I see.
Okay, so the number that you choose, the s that you choose, add up will give the same value of the b, of the constant. Okay, so this is the technique that you can apply to solve or to find the constant for linear factor. I'm not going to show the second approach here, but you can try the second approach if you prefer with that, and you can see that it will give you the same answer. Okay, we are not finished yet. Okay, do not left your step until find the value of constant here. Okay, always end up your solution with the final answer. Write the final answer. Yes, this one. Okay, write your final answer as this one.
Okay.
S plus 2 over s cubed minus 2s squared plus s, and then your a just now is 2, so 2. B negative 2, so negative 2, and C is 3. Okay, this is your final answer. Okay, any question regarding case number 2?
No.
Okay, so now I proceed to case number 3. Case number 3, distinct irreducible quadratic factor. Distinct irreducible quadratic factor. So the given example here, okay, lucky, it is already in factor form. So as you can see here, the first factor is s minus 1. So it is a linear factor. And the second factor is s squared plus s plus 1. S squared plus s plus 1 is irreducible quadratic factor because you cannot reduce it anymore. So this is okay. So it is combined the first case and also the third case. Okay, it combine linear factor and also irreducible quadratic factor. Okay, for example number 3. S minus 5 over s minus 1 times with s squared plus s plus 1. Okay, so how many factors that you have?
3. X
Okay.
minus 1. And then after, just use a calculator. Okay, then
X plus 1 squared.
x minus half. Sorry, x plus half.
S plus half square.
Yes. Then you can
Yes,
expand it to x plus half, x
S
plus half.
square plus s plus no.
Penalty S perempat.
Yes, supposed to be 1 over 4, isn't it? If you expand it. This is wrong.
No.
So that this is irreducible quadratic factor. You cannot reduce it.
Oh wait, you cannot. Or half cannot exist, right?
Half exists, but when you expand it, you will get s squared plus s plus 1 over 4. Not plus 1. Okay, so for this case, there are 2 factors, which is the first one for linear, the second one for quadratic. For quadratic, okay, for linear first. For linear, it is A, but for quadratic, you have to put Bs plus C.
Why? Why?
Okay, look at here. For the third case here, third case here, the one in the blue box, As plus B, where you have Q, As squared plus Bs plus C, where it is irreducible quadratic factor. Okay? So
Alright.
Okay, so basically it is like when you have a linear factor, you have to write as a as power of 0. Sorry. It's only a. But when you have as squared plus bs plus c, you have to put as plus b.
I see.
So when you look at the degree here, the highest degree is 1. So at the top part, it reduced by 1, which is 0. The highest degree here is 2. So here is 1. So the numerator part is with degree reduced by 1. You see that? That's why when you have linear, you just put a. When you have quadratic, you have to put as plus b. Okay?
I see that. Alright. To make it as a rational, yeah. Proper rational.
Yeah. So I continue here.
Wait, Miss.
Which one? Yeah,
If
yeah.
reason for ax plus b is like that is to make it proper, then leaving it in b over ax squared plus bx plus c is also proper what?
You mean for quadratic part?
Yeah.
Okay, for this one,
Or is it just that if the bottom power increases, the top power has to increase too? Is that
the top part, the power at the top part is reduced by 1 degree from the denominator part.
oh okay? So you just minus 1. So if the
Yes.
bottom was 3, then the numerator power is 2.
As for now, we just discuss up until quadratic factor.
Oh, okay, thank you.
Okay. So you just have these two conditions as for now.
Okay, thank you, Miss.
Okay. So since here for the example 3 here, the degree at the numerator part is 2. So the numerator part, the top part is 1. Okay. Okay, so the first step here is very important. Okay, the way you express your partial fraction. Okay, if you wrongly express it, you will end up with a wrong conclusion. The wrong answer, because you will find the wrong constant later on if you express it wrongly. So careful here, when you have quadratic, you have to make sure there are 2 terms on the top. When it is a linear, it's only 1 or single term on the top. Okay, the next process is similar as what we have discussed earlier for the first and the second case. Okay, so for this one, you have to make the denominator same.
Okay, then from here we do the same thing again.
Okay.
Wait, isn't it x minus 1?
X minus 1, right?
Yeah, the denominator there.
Oh, okay.
The right side, yes.
Okay, compare the numerator part. Okay, now we can how? Since you have linear factor and also quadratic factor, so I would suggest here apply both approaches. So for the first one, since you have a linear factor here, so s minus 1. So from s1 minus 1, you can get the root s equals to 1. So substitute s equals to 1 to the numerator part here. So you will have 3 times 1 minus 5 equals to 1 minus 1 is 0. So a 1 squared plus 1 plus 1 plus 0. 3a equals to negative 2. A equals to negative 2 divided by 3. Okay. And then to find b and c, since there is no more linear factor here, so you have, I suggest to use the second approach, which is you have to expand the right hand side expression. So as squared plus as plus a plus bs squared minus bs plus cs minus c, and then group the like term. So s squared with s squared. So the coefficient of s squared is a and b.
A, B, and B.
And then group the coefficient for x, which is a and minus b and plus c.
C.
Okay. And the constant is a
And C.
and minus c. Alright, so now find what is the missing term at the left hand side.
X squared. So A plus B equals to 0.
Yes, so put 0 coefficient for the missing term. Okay, we add 0 coefficient for the missing term. Is it okay now?
Yes.
Can you follow me, guys?
Yep.
Until this step, then you can compare the coefficient. Okay, we start from s squared. Okay, for s squared, what is the coefficient that you have at the left hand side and the right hand side? It is
0
0
equals
and,
to a plus b.
okay, good. And then for x, at the left hand side you will have
A minus B plus C equals to 3.
Yeah.
Then A minus C equals to 5. No, wait, A minus C
Negative
equals to
5.
negative 5, yeah.
okay. Oops. Three equals to a minus b plus c, and the
Negative
last
5.
one is constant. For the constant, you will have negative 5 and a minus c. Negative 5 and a minus c. So from the first, from a, you already have the value of a, so that b equals to negative a, b equals to 2 divided by 3. And then you can use the constant here instead of x. Constant to get c. C equals to a plus 5. So what is a?
A equals to
Negative 2 over 3.
So c equals to 13 divided by 3. Alright?
Miss,
Yes.
can you just scroll up a bit, please?
Up.
Yeah.
Or maybe I zoom.
Oh, okay. Okay. Thank you.
Okay, so now all the constant already there, so you have to substitute to the expression in order to have the final answer. So that's the final answer. S minus 5 over S minus 1 s squared plus s plus 1, it is equals to, what is a? A is negative 2 over 3 over s minus 1 plus b is 2 over 3 s plus c is 13
over 3
3
over x squared plus x plus 1.
s Okay.
Alright, that's understandable. Still good. We're still good, right, guys? This is fine.
My brain is like dying.
It's okay. I think this is the worst we have to encounter. I think.
Here is almost the answer. Okay, so if there's no question, let's continue to the last case here.
There's more.
The last one, case number 4, where you have
Alright.
repeated irreducible quadratic factor.
Alright.
Mirza, I think this is it, Mirza. Big one.
Mm-hmm. Oh yeah, there's 4 factors. Wow. Factor 4 is gonna be the end of all.
Okay,
Find the battle.
s cubed plus s squared divided by s squared plus 4 to the power
Oh
of
my goodness.
8. Again, in order to perform or in order to express it in partial fraction. Okay, first you don't have to worry about the numerator part. Okay, the numerator part can be any polynomial, functions, or just a constant. Okay, but you have to focus first is at the denominator part. Okay, if it is not in factor form, then you have to factorize first. But for this case, example 4, it is already in factor form, which is repeated irreducible quadratic factor. So for this one, in order to express these factors, the repeated quadratic factor, cases you have
Expand
2
first.
factors here. So 2 factors, so you will have 2 fractions. The first one is s squared plus 4, same as the repeated linear earlier.
And x squared plus 4 also for the other one. Right?
Yeah.
Yeah, this
Square.
doesn't
Right?
seem too hard. Oh wait, no, I forgot this is square.
The first one power of 1, the second one is power of 2.
2, yeah.
Alright, so
I forgot this was the thing.
for the first, okay, again, since this is quadratic factor, so you have to write 2 constant on the top, which is
A and B.
so as plus b.
Oh wait.
As plus b, this one. And then for the second factor is cs plus d.
Oh, there's d now.
Alphabetical order. If let's say you have the highest degree is 4. Okay, for example, 1 over s squared plus 1 to the power of 4. How many constants that you will have?
You will have 5
5.
constants.
5, yeah. 5 or 4?
4?
I know,
If the highest
4.
degree is 4, how many constants? I mean, how many a and up until?
D.
No, Mirza, I don't think so. You will have 8 constants.
Yeah.
Because for each denominator, there are already 2 constants. You have ax plus b, then cx plus d, then after that.
Yeah.
Dude.
Yeah. You know. No.
No worries, it's just an example. You don't have to solve up until power of 4. Okay, no, you can up until power of 2. Okay, so for example, this one, since the power is 4, so the first one power of 1, 2, 3, and 4. And since this is what? Okay, this case is repeated irreducible. Okay, so for the numerator part, you will have the first one is as plus b. Then,
cx plus d,
yes, cs plus d.
ex plus f, then gx plus h.
What the heck was GX plus? Okay.
So how many constants?
I've lost count of my ABCs.
5, 6, 7, 8.
8 constant. Yes, so the constant is 8 if you have the highest degree is 4. Okay, so
This is so
the constant
complicated.
is
Can I get an F in chat?
okay. So now, can you get the idea how to express the problem, the case that involve repeated quadratic factor?
Yes.
Good. So now let's continue. Okay, the next step. Okay, again, make the denominator same. So we multiply the first fraction here with s square plus 4.
Plus 4 square.
Huh?
Wait, what? No square?
No square, right? Because the common denominator is
Oh,
s
wait, no.
square plus 4 square.
Yes. Yan Wei. Yan Wei.
Never mind.
Okay, so the first one we just multiply with s square plus 4, and the second part remain the same.
CX full dot. Never mind.
Okay, so compare the numerator part and find A, B, C, D. Can you use the first approach here?
No.
No, because there is no linear factor. So the only approach that you can use is compare the coefficient. So you have to expand first. So as cubed plus 4ax plus bs square for b, cs cd. Sorry, am I right? cs plus cd. Isn't it?
Yes.
Plus cs plus d. Is it bracket or C? Oh, it's supposed to be no bracket here. Okay, sorry guys, I'm confused with my handwriting. Okay, CS plus D, so no, it's supposed to be CS plus D. Okay, then group the like term, the same terms together. So and put the missing coefficient. The missing coefficient at the left hand side is what?
X and constant.
Plus 0s plus 0. Then for the right hand side, we group it together. So for s cubed, no other terms. Bs square. For s, we have for A and C. And for the constant, we have D. For B and D. Okay, for the constant, for B and D. Okay, then you can compare coefficient. Okay, so for A equals to
A equals to 1.
A equals to 1.
Okay,
For
this looks
B,
similar. B also equals to 1. Oh, okay, this is
B
not
equals
so
to
bad. This is not so
1.
bad.
Yeah. Yes.
Then 4A plus C is 0, then 4B plus D is also 0. Hey, okay, that's not too bad.
Okay, so this one for s cubed.
Yeah.
And then s
Itu
square
aku.
for x.
C equals to -4.
Okay, to solve C. C equals to -4A.
4. Same goes to D.
What is A? A is 1, right? So C
Yeah.
equals to negative 1. Okay. And for B, A, B, C, and what D?
Same.
B equals to negative 4B. So B equals to
Juan. El Juan.
okay, so A equals to 1, B equals to 1, C equals to negative 4, D equals to negative 4. Okay, so that you can write your final answer as A equals to 1, so as B equals to 1
Oh my goodness, I just realized how many workings there are.
plus C equals to negative 4, negative 4 also for D divided by S square plus 4 square. Okay, so this is your final answer. Okay, so that's all the 4 cases that you need to consider in this part, okay, in this chapter, in order to write into partial fraction. Okay, so I think that's all in this subtopic. Is there any other questions?
No, I don't think so.
No.
Okay, so I will give you an exercise, okay, for this question. Okay,
Not yet, Mirza, not yet.
Alright. Dia malah. Dude, lab code, you know, I'm gonna go be like the which anime? The
Steins Gate.
Steins Gate kan the another anime
Dr. Stone.
wearing
okay, look at this question. There are 4 questions. Okay, the first one here,
Okay.
x minus 11 divided by 6x squared plus x plus minus 2. Okay, can you please state the type or the case for question number 1?
Okay, I am working on it.
Okay,
it's
This is
second factor. Yeah.
this is a case of distinct linear factors.
okay, good. These are linear factors. What about the second question here?
Second question.
Maybe
Wait, Wait, I can't see the question anymore.
Alright, this was the first and second question. Okay, hold on. I will crop the third and fourth question as well.
Boleh.
Okay, the second one is also 2 distinct linear factors.
Are you sure?
Hey, no, wait.
Okay, actually I prepared 4 questions that represent all cases, all the 4 cases. Okay, so for your own exercise, okay, the first one, okay, yes, good. It is distinct linear factors. Okay, when you have the denominator part, when you factorize it, what will you get? For the first question, it is?
You will get
This part, it is 2
you will get 2x plus 1.
plus or minus.
So minus 1, sorry. And for the second one, you will get 3x plus 2.
Okay, good. 3x plus 2. So this
Distinct
is
linear
case 1.
factors.
Yes, case 1 is linear. So when you express it as minus 11 divided by 2s minus 1 and 3s plus 2. So it is equals to a over 2s minus 1 plus b
Over 3x plus 2.
3s plus 2. And then
Oh, I got a
by your own
email.
reference. And
To
then you
Mr.
can find
Shaslane.
it. Okay, I just share here the final answer, the constant. Okay, and then Okay, you can check it later. Okay, please complete all these 4 exercises so that you will be familiar with this question. B equals to 5. Okay, this is the answer for the first question. Okay, now move to the second question. 3s squared plus 7s plus 1 divided by s cubed plus 2s squared plus x.
Okay, first we have to factorize x out of the denominator, right?
Huh?
After that we get x bracket x cubed plus 2x plus 1.
Uh-huh.
Okay, then
Can
this
you
means,
further factorize?
yes, you can x minus, or is it minus 1? Yeah, I think it's minus 1 square, or plus 1 square.
Okay, s plus 1 squared. Okay, now when you express it into partial fraction,
X plus 1, X plus 1.
equals to, okay, how many fraction?
3,
Okay, the first one is x, and then
x,
x
a,
plus 1.
Oh.
Okay,
x plus 1 square at the end.
s plus 1 squared. Good. And what's the constant here?
C,
Okay, c.
Yes.
Right. So for the answer, a equals to 1, b 2, and 3c.
wait, I have a question.
Huh?
This is considered, what kind of factors is this?
What kind of factor?
Yeah.
It is a repeated linear factor, case 2. But it combined with the first case as well. Linear factor and repeated linear factor.
Because there's x also, right?
Yes.
God, this is confusing.
So it can mix together case 1 with case 3, case 2 with case 1, and so on. Okay. Okay, so now Question number 3. Okay, the denominator part here, it is s cubed plus 2s squared plus 3x.
Factor out x again.
Okay.
Then you get x bracket x square plus 2x plus 3.
Can you further factorize it?
Let me check.
Okay.
X,
Brain is failing.
X plus 3, X minus
Yes,
1.
you can further factorize it into x plus 1 square.
S plus 1 square? I don't think so.
Wait, no.
3,
If s plus 1 square, s square plus 2s plus 1. Now you have plus 3. So you cannot further factorize it. So this is irreducible quadratic factor. Okay?
I see.
So when you express it, you will have e over s plus, what is the top part here?
Bx plus c.
Yes,
B, X plus
bs plus c, because this one is irreducible. So the answer for question number 3, A is, okay, let me check, where is A? A is 2, B is 3, and C is negative 1. And the last one here is 2s cubed plus 7s plus 5. And the denominator part s power 4 plus 4s squared plus 4. How to factorize the denominator part? Now you have the highest degree in 4.
X, bukan.
Okay, let me show. Since you have, when you have the highest degree, for the first term is 4 and the second one is 2. Okay, I suggest you to use this technique by let any variable that you like. For example, here I choose m equals to s squared. So since you know that from the expression here, s power 4 is also equivalent to s squared squared. plus 4x squared plus 4. And then substitute x squared to the m squared plus 4m plus 4. Now you have a quadratic expression in terms of m. So can you factorize it now?
Yes, you can factorize it now.
So it becomes m plus 2 squared.
2 square.
Okay, let's substitute back the m with x squared. So this is how to factorize x power 4 plus 4x squared plus 4, which is equals to x squared plus 2 to the power of 2. So as you can see here, it is a repeated linear factors, case number 4. Okay, so when we
Wait,
express
linear factor?
sorry, quadratic factor.
Yeah.
Repeated quadratic factor. First one x squared plus 2. The second one is x
X
squared
square plus 2 square.
Okay. The first one on the top is
Ax plus b, cx plus d.
okay. So the answer for this question, okay, I'll share here. A equals to. Okay, don't forget to completely write the final answer. Do not just leave your step until finding the constant. Because 1 mark will be given for the final answer. C3 and D is 5. Okay.
Okay.
Alright, so we end our discussion on chapter 3.3. Okay.
Wait, miss,
Yes.
I have a question.
Okay.
Why is the numerator ax plus b and not just like a?
Because here you have a quadratic factor. This is not a linear factor. It's a law.
Yes.
Okay, thank you.
Alright. Okay. Okay, maybe you can try first these all 4 questions to understand what we have discussed for chapter 3.3. So later on, I will upload in ULearn the recording for lecture on 2.6, 3.1 and 3.2. So for the next lecture on tomorrow, right? Our next lecture.
What?
Our next lecture is on tomorrow, Thursday. So tomorrow we will continue to chapter 4.1.
Got it.
Oh,
Okay. Alright. So we try to do the revision for your test 1 by next week. Okay, which
Okay.
is your second. Okay, thank you everyone. That's all for today. Don't forget to sign in your attendance.
Miss, the forms is not accepting responses. Check the chat.
Okay, let me check the setting. Okay, I will update you soon. Thank you. Okay, see you guys.
Like
Have a
this.
nice bye.
Bye, miss.
Hello. Oh my goodness.
Thank you, miss.
Welcome.
Thank you, miss.
Okay.
Alright.